Good afternoon and welcome to our next session, Whale Conservation in the 21st Century. My name is Carole King and I serve as the Development Director for the National Marine Sanctuary Foundation. Like all of you, protecting these iconic species is near and dear to my heart, and I'm really looking forward to this discussion. Thank you for taking time out of your day to spend with us. To kick us off, I'd like to bring to the stage Dr. Peter Thomas, who's the Executive Director at the Marine Mammal Commission. The Marine Mammal Commission is generously sponsoring this important panel, and it's great because our sponsors allow us to keep this conference free and open to the public, and we're very grateful for the support. The Marine Mammal Commission provides independent, science-based oversight of domestic and international policies and actions of federal agencies addressing human impacts on marine mammals and their ecosystems. They work to ensure that marine mammal populations are restored and maintained as functioning elements of healthy marine ecosystems in the world's oceans. Please help me welcome Dr. Thomas, and thank you for your critical work and support.
So I just have a few remarks from the podium as our panel gets seated. Again, the Marine Mammal Commission is very pleased to be the sponsor of this Capitol Hill Oceans Week session on whale conservation in the 21st century. The Marine Mammal Commission is an independent, science-based federal oversight agency. We work to conserve and protect marine mammals and the ecosystems they inhabit as mandated by the Marine Mammal Protection Act. We work on marine mammal science, policy, and conservation related to species of particular concern, with a focus on critically endangered species such as the North Atlantic right whale or the vaquita porpoise, or endangered populations such as the Cook Inlet beluga and southern resident killer whales in Puget Sound. We work to address the broad threats facing marine mammals, including entanglement and fishing gear, ship strikes, impacts of ocean noise, and the responses of marine mammals to the changing oceanographic, ecological, and prey conditions that accompany climate and ocean warming. Our purview extends from the high Arctic to the tropics, and our focus is not only on the health of populations, but the health of individuals. I'm going to just introduce our panel very quickly and walk over to the other spot, but many of these species and themes will be covered by today's panel as we provide a window into promising technologies and tools helping us better understand whale biology and enable us to better address the threats to large whales. Not yet. Okay. So it's more comfortable here. To introduce the panel, I think I'll give a kind of overview, and Michael referred to it as a sort of drone shot of where we're going. We'll start at Stellwagen Bank Marine Sanctuary off of Massachusetts, where innovative photographic techniques are being used to help us better convey the message of the lives of large whales and other biodiversity to the general public. Then we'll zoom out more broadly to New England and Eastern Canadian waters to focus on ropeless fishing technologies, which can provide alternatives to the traditional lobster gear, which is entangling North Atlantic right whales and threatening the recovery of that species. Then we're going to go across to Cook Inlet, Alaska, to another small and very vulnerable population of Cook Inlet beluga whales. So despite their endangered designation and a ban on traditional subsistence hunting, the Cook Inlet population is not recovered. We'll hear about drone sampling of whale blows and other biometrics, which is ground truth from both more healthy wild populations as well as captive populations, to evaluate the question of how much stress is involved in sort of hindering the recovery of Cook Inlet beluga whales. Now that we're in Alaskan waters, we're going to start looking at humpback whales, which feed here and migrate south to the Hawaiian Islands. So we just held our annual meeting in Hawaii 2 weeks ago, so it's really great to discuss this. There are some real questions about the health of humpback whale populations relative to changing environmental conditions. So as we go to Hawaii, we'll look at the technologies used to track these animals and assess their health. And finally, coming full circle back to Hawaii, we'll get a glimpse at the tools used in the very immediate critical situation of whale entanglement and get back to this question of disentanglement and the entanglement of whales in fishing gear. So I'm really pleased to have a bunch of friends here for the panel. Mr. Keith Ellenbogen is Assistant Professor of Photography at SUNY Fashion Institute of Technology in New York City. He's a visiting artist at the Massachusetts Institute of Technology and recipient, relevant to here, of the National Marine Sanctuaries Foundation Hollings Ocean Awareness Award to raise awareness of the diversity of Stellwagen Bank Marine Sanctuary. Dr. Michael Moore is chair of the Ropeless Consortium Board and senior scientist at the Woods Hole Oceanographic Institution, where he's head of WHOI's Marine Mammal Center. He's just finished a team as chair of the Working Group on Marine Mammal Unusual Mortality Events. Dr. Tracy Romano is vice president of biological research and chief scientist at the Mystic Aquarium in Connecticut. She's an expert on marine mammal health and has been developing and utilizing non-invasive techniques to study the health of marine mammals with a focus on belugas in Alaska. And finally, Mr. Ed Lyman is large whale entanglement response coordinator at the Hawaiian Islands Humpback Whale National Marine Sanctuary. In addition to whale entanglement response, he uses technologies such as drones, cameras, and biotelemetry to support broader health and risk monitoring of humpback whales in the Eastern Pacific. So to start our drone tour of the United States, we'll start with Keith, who will talk to us about using photography to raise public awareness.
Great. Thank you very much for the introduction. Nice to meet all of you. So I'd like to just start for a second and give a little background. So when I was 16, I actually volunteered at the New England Aquarium. And that same year, I learned how to scuba dive off the coast of Gloucester in Massachusetts. It was snow on the ground, and I had my first experience in the water. My grandfather, an amateur photographer, gave me my first camera, and I just started diving and taking pictures ever since, mostly because I loved it. I then also went on a whale watching boat and was inspired by the nature that I saw, whales off the coast of Boston. And I think altogether began to sort of just leverage my own ability of storytelling through the art of photography and the enjoyment of bringing back the nature and wildlife off our coast. One of the challenges is I've been very fortunate to travel all over the world to be able to photograph marine wildlife. But of all the places I've ever been, the most extraordinary place is right off the coast of Boston in Stellwagen Bank National Marine Sanctuary. And I look forward to sharing with you a few of these images. So the perspective that most people see, or the reason people come to Stellwagen Bank, is to see humpback whales for the most part. And here you can see one at the surface, and that's pretty much our view. And then every now and then they breach out of the water, and universally everyone seems to always go oohs and ahs, and a real sense of excitement as they see a 50-foot animal just launch itself out of the water. But let me just tell you where we are. So Stellwagen Bank is about 25 nautical miles off the coast of Boston, just in between Gloucester up north and Cape Cod down on the south. And so to access this place, most people need to get there really via a boat. And off the coast, this is how most people get there. They go to whale watch. And this is a good illustration of an example of safe distances for whale watching, being able to observe the humpback whale you can see in the foreground. And it's viewed and inspired by many people, fishermen, recreational people on boats, and whatnot, who are interested in just watching and getting a glimpse of its tails. Off our coast are also, what you might be surprised to realize, are fin whales, the second largest whale in the world, lunge feeding here just off the coast of Provincetown. Sorry. And then we have North Atlantic right whales. There are only about 500 of them left, and I've been working with a pilot to be able to capture these images of flying overhead, in which they're swimming in very shallow water, just inches off the surface, feeding on the nutrient-rich water, our plankton, that is so abundant in there, and why these animals come through our area. And if you ever are fortunate to be able to see one of them, here's how they feed, just with their mouth wide open. And I had a magical day one day where I just sat in the bay on the water, and a right whale like this was zooming in and out just over and over for an hour, coming closer and closer to the boat. It was the most incredible experience. It was like mowing a lawn, just coming in, feeding on the plankton. And it did this, it was incredibly slow. And you can see here how they feed with their mouth open, wide, just constantly feeding off of the plankton. But this is the view that most people see, is a surface level view. And so now what I want to do is try and take all of you underwater for a minute to experience what it's like to photograph a humpback whale. In order to do this, I have, first of all, a NOAA Marine Mammal Photography permit, which allows me the unique access to be able to go into the water and to be able to photograph these animals. Now, the challenge in New England, and especially in our part of the world, is that whales are doing two things. One, they're actively feeding in that area. That means they're constantly moving in search of all the food. Unlike in other areas, possibly where there's clear water, that are just sort of there and not moving as much, here they're active. And 1 knot or faster for a whale is an incredibly fast pace for me. The second challenge is our nutrient-rich waters, which is why the whales are here, makes visibility very difficult. This is 25 feet away from a humpback whale, and you can barely see it. So there's my first challenge. As I start to break the barrier, and I should say that I'm looking to work with, in order to capture these images, working with the NOAA Stellwagen Bank team, the scientists, the naturalists, the captains to be able to get it, and here at 25 feet. And again, these whales, while stopped in motion through photography, are actually moving. And then it descends down below, and I try again. And over the year, it took me, in order to capture this one moment where I was able to break a 15-foot barrier and had an incredible encounter with this humpback whale. And this is the first picture of a humpback whale underwater within our natural resource of Stellwagen Bank National Marine Sanctuary, and begins to tell a story of the underwater world. And I'm going to pass it off after this, but this is just one of the iconic animals that really communicates why our sanctuary is so important, and to really be aware that, to give a whale's perspective to the underwater world. So thank you very much, and I'll pass it to Michael.
Well, thank you. So, unfortunately, I have to show you some rather more disturbing images, or at least one. But first, I'm going to give, oh, can you go back, please? There should have been a video for that previous slide. Can you click on that, maybe? So anyway, I've had the privilege of working behind the screen of a drone in Cape Cod Bay for the last 3 or 4 springs. And if that video was working, you would see what I was seeing, which is the ability of these animals to skim feed, as Keith was saying, and the remarkable way that they can go through the water and capturing the prey as they go. So just don't mess with it, just leave it there, because we can use the still. So what I wanted to show you in the video was how these animals, as you saw earlier in Keith's photographs, go through the water with their mouths open for a significant amount of time. And it's one of the most beautiful things. It is magical. People that have got the right day, with the right whales, the right weather in Cape Cod Bay to see right whales skim feeding are never the same again. It is an extraordinary experience and privilege to see. So anyway, but those mouths stay open for a significant amount of time as they're mowing the lawn, as Keith said. And that is a huge risk, both for the fact they're on or near the surface from a vessel collision risk, but also it's a natural funnel into which rope can get entangled through the baleen plates. And what happens is, as the whale feels the rope, they startle, they twitch, and they very often spin, and they thrash, and the entanglement results in that. So the end result is cases like this. So this animal was last seen gear-free in February of 2010. And the Christmas Day of that year, this photograph was taken by colleagues in Florida. And there is a number of things to see from this photograph. It's pencil thin. These animals should be more like a cigar, not like a pencil like that. It's a lot of loss of weight. It's been dragging the line through the water column for months, for sure. And the rope is in both sides of the mouth. And in fact, on the right side there, that rope looks like it's embedded in the lip. And when it died 2 weeks later, we noticed that it was. So you've got a piece of rope embedded in the flesh of the animal, and it's dragging a whole lot from the other side as well. And the cost to that is loss of weight and other stresses, immune suppression, and obviously there's going to be some cognitive stress as well as that. You can see the scars on the tail there as well. So this rope, it was 7/16 inch diameter rope, and there was a piece of a wire mesh plastic coated trap, most commonly seen in the Gulf of Maine as a lobster trap, but also significantly these animals are being entangled in snow crab traps in the Gulf of St. Lawrence as well. So this cartoon here, drawn by a colleague at Hui, gives you a sense of the status quo with regards to these situations. So you've got a string of traps or a trawl along the bottom, and we've regulated now such that those traps are, the bottom line between the traps is negatively buoyant. But ultimately, the real remaining risk is the line from the end trap up to the surface buoy. Now that line is important for the fishermen to be able to retrieve the trap to, thanks a lot, to get the harvest and also to rebait it. But also the buoy at the surface is important to identify where the trap is and also whose trap it is, so the owner of the gear can come pick it up and do what he has to do. But meanwhile, if the whale swims through with its mouth open, it touches it once and it starts to spin and you get entangled around the flukes and the mouth and the flippers. And it's really a very serious problem, to the point where 83% of North Atlantic right whales show scarring from entanglement. 72% of the mortalities that we've diagnosed in the last 10 years were due to entanglement, and 25% get entangled every year. So the majority get out of it, but the minority die. But many of those animals that are not dead but entangled, and certainly that previous slide I showed, that animal was a dead whale swimming whether it was dead or not, because it was never going to get pregnant again, and it essentially was out of the gene pool. So the sublethal effects of these entanglements are just as, if not more important than the mortality effects as well. So where does the technology come in here? Well, what you're seeing there is very much of a centuries-old traditional way of catching lobsters. And it works really well, and it's profitable, and why the hell do we want to mess with it? And folks like myself have been described as being completely out of touch in terms of what we recognize as being practical for the industry. So the question is, how do we go from that previous scenario with the rope from the bottom to the top to this one where the whale can swim free and you've got an acoustic link, a virtual end line, if you like. So the boat is doing two things acoustically. One is that there's an acoustic marker on the trap which shows up on the plotter on the vessel. So that'll give you a sense of where the trap is. Instead of looking out of the porthole, you're looking at the screen to say, well, who's got gear where and how can I avoid that? And where's my gear and how can I deal with it? But also it'll actually tell you where the gear has gone when you've lost it too, which won't be the case with the traditional method. And the second acoustic trick is to release some kind of device that will enable the retrieval of the trap without having an end line. So in that case, you've got a buoyant spool with rope. When you hit the button, it'll come up. Or you can have a bag that opens up and a buoyant piece of rope comes out, or an inflatable bag, like a salvage bag for a ship. So those are the technological solutions. They all exist in terms of research and industry and defense, but they're not affordable as yet for the scale of your average lobster fishery. So it all comes down to the relationship between science, regulators, managers, the industry, and the elected representatives of both the fishermen, this gentleman here, fishes in Boston Harbor. And I use this photograph primarily because they already use a ropeless system. They actually use a grapple because there's too many boats in Boston Harbor to enable the gear to survive. It gets trashed by the propellers. So with a virtual marker on the trap, you could actually do just fine with a grapple too as a low-cost solution to that. So what we've done is we started this thing called the Ropeless Consortium. Ropeless.org is the website. We have a third meeting coming up on November the 13th in Portland, Maine, and we'll be discussing experience of people working with the industry, working with the technology groups to figure out how this is all going to work. So in summary, the goal is to conserve trap fisheries and the North Atlantic rail. They both have fundamental global capital. Fisheries support coastal communities and provide seafood. Whales have a major evolutionary heritage in cycle energy and nutrients. We need to collaboratively evolve affordable, safe, and humane strategies to enable both the fisheries and the whale to flourish. It requires new investment in technologies that minimize trauma from rope in the water column, but we can do it. The question is the will to do it there or not? Or are we going to essentially have a stranglehold on legislation, regulations that already say you should not be killing right whales, but we seem to be unable to achieve that goal with the political, the socioeconomic value of the industry. And we're not valuing the biodiversity enough to really have that balance. Thank you.
Now we'll shift to Alaska.
I'm really grateful to be here today and to share with you the work that we're doing at Mystic Aquarium, the new technologies that we're developing, and ground truthing on animals in our care that contribute to conservation of the animals in the wild. The 3 pillars of our mission at Mystic Aquarium are conservation, research, and education. And I'd like to focus on 2 opportunities of having these animals in our care provides for the animals in the wild. One is the ability for education and outreach, to educate the public and engage 800,000 people a year, plus millions of students on the threats of belugas and what's happening in their environment. The second is research and learning as much as we possibly can about the animals in our care. And research in aquaria really provides 3 opportunities that studying the animals in the wild doesn't. The first is that we have controlled conditions. We know what the animals are eating. We know when they last ate. We know how much they ate. We know their health history. We know all the parameters in their environment. So that's 1. 2, we're able to train these animals to give us biological samples that we can then take to the laboratory and develop the tools and technology to study wild populations. And 3, we can train the animals to participate in experiments such as echolocation experiments, diving physiology, and hearing studies that will help inform conservation. And all of the work that we do at the aquarium translates to contribute to our general knowledge on belugas, conservation of belugas, as well as in informing recovery of endangered populations, such as that population in Cook Inlet that Peter mentioned. Our overall goal is really to try to understand how environmental and man-made stressors impact the health of marine mammals in general, using the beluga as a model. So one of the things that we can do in the aquarium is we can train animals, as I mentioned, to give us biological samples. And what we've done in the past is really focused on blood. Blood is the gold standard of health. When we go to the doctor takes a blood sample, and that's a window into our health. We do the same for the health of marine mammals. However, it's very difficult to take a blood sample in a free-ranging whale. So what we're doing is we're looking at non-invasive tissue samples such as breath, feces, saliva for more of the in-house aquarium research studies. But what can we tell from those tissues? We can look at reproductive status, we can look at physiological responses to stressors, we can look at immune components and a variety of different parameters and a window into health, into what's actually going on in these animals. And importantly, we can transition these, we can utilize the aquarium animals in our care. For example, if we use the next step to translate to free-ranging populations is using a drone. Well, how low or how high can that drone be before we still get a signal? So drones are being used in right whales and humpbacks, but the plume, the blow is fairly large. In belugas, it's fairly small. But we can ground truth all these different techniques and then transfer them to the wild. And I just want to show you with these videos, these are how our whales, some of the behaviors that our whales are trained for. These not only contribute to understanding their health and monitoring their health, but again, for research purposes. If we could go to the next slide. The other area of technology are molecular technologies, sequencing and genomics and transcriptomics. They're really revolutionizing what we can learn about health. And one of the things I'm most excited about is in free-ranging whales, you can get a skin biopsy. And in the past, we've used skin biopsies for population genetics, for contaminant information, as well as hormone levels. But now we can look at the multitude of genes that are expressed in belugas through their skin. And so we're ground truthing this, and we have skin samples that have been collected from Cook Inlet belugas, St. Lawrence belugas that are on the decline, as well as healthy populations such as Bristol Bay and the Chukchi Sea. Photogrammetry is really looking at body condition and pregnancy status as well as population studies, but again, using drones, as Michael showed, using drones to take photographs or video of the animals from above. And you can see this photo taken from a drone from the St. Lawrence estuary for 3 belugas, and then a photo that mimics drone activity in an aquarium. And the whales were actually trained to swim underneath the camera. We then were able to take the photograph, but importantly, our whales were then trained to take all kinds of measurements. And also, we take routine weights on our animals. So we're providing all this data to the wildlife biologists in the St. Lawrence, and it's available for Cook Inlet as well, to help ground truth some of the data that they're collecting on pregnant versus non-pregnant, as well as animals in different life stages. And the last technology I'm going to talk about is telemetry devices and cameras. Testing these expensive new technologies on whales and aquaria really provides an efficient means for launching them in the wild. So we've been working with our scientist in resident, Greg Marshall, who invented CritterCam, or cameras that you put on the backs of animals to see through their eyes. And really, we were able to show with our animals the best attachment methodology, the best placement, how long the camera would stay on, and to make sure there was no adverse behavioral reaction. And we're partnering with others to study wild belugas. We're partnering with the Alaska Department of Fish and Game and the Department of Wildlife Management in the North Slope Borough who are tracking whales. They're putting satellite transmitters on whales to see where they go and to look at their diving frequency, how deep they're diving. And our part is to take blood samples, skin, and breath to assess the health from these animals. And it's really the partnership with the native people and the scientists and the other agencies that really help with conservation. So in summary, all of these new technologies that are ground truth in aquarium belugas are contributing to our understanding and helping with the conservation of whales in the wild. Thank you, Tracy.
Well, aloha, everyone. I'll wait for the slide to come up, but I want to take you from Alaska to Hawaii to look at another population of whales, the Central North Pacific stock of humpback. Let me hit that again, just make sure. Central North Pacific stock of humpback whales, and a very important species. I'm going to take you down to Hawaii, their principal wintering ground for the North Pacific, take you to where I work, the NOAA's Hawaiian Island Humpback Whale National Marine Sanctuary, where our primary goal is the conservation and protection of this species and its habitat. Going to cover several different roles, and actually going to throw another image, not competing, Keith, but you know, in our role as far as the messaging, education, outreach, boy, imagery is a great tool. It's one of the tools there. And then there's research, there's the resource protection. It's those latter two that I want to address here today. And, oh, that's out of sync, okay. That's not supposed to be there. Let's see what happened here. jumped way ahead for some reason. Okay. Well, let's go with this, okay? I'm going to jump ahead to another aspect, and that is the whale disentanglement, okay? We like to call it entanglement response. It is like the science of monitoring these animals. And that's what I wanted to say. We're like the doctors out there and using all the tools you've heard. And I know that was a little jumpy, and that shouldn't have been in there, I think. But you can see we're trying to cut a whale free. We're using techniques like kegging to slow it down and get a hold of it and to make more assessment. What this really comes down to is that we're trying to reduce the threat overall. And yes, at the same time, we get to cut a whale free. Okay, so there's that animal welfare side, and on certain species like the right whales that we've been talking about, that is important at the population level. But for the humpback whales, it's save a whale and gain information towards science to reduce this threat. Let's see what else we've got going here on our slides. Okay, and that's all that's about is our goals. It's all about, mostly about gathering information to reduce the threat. Let's see if we're going to go. Okay, boy, we skipped a lot of slides there. Okay, but the other thing I wanted to tell you about was all these tools that we've been talking about here, the drones. Well, let me put it this way. For 17 years, the sanctuary has been doing this program of risk and health assessment. Okay, and the idea there being, even though humpback whales in that area off the endangered species list, is keep a finger on the pulse. Be the doctors. Have multiple doctors, collaborate, partner, and have your specialists come in that, have the drones and have telemetry. They do the tagging. Okay, we work together. So I had an array of images that showed everything from visual health assessment, very basic, but then taking those cameras that were on boats and putting them on poles and getting them in the water, okay, and getting underwater views. Again, that one shot of just in Hawaii, that clear blue water is spectacular. Okay, and then taking them and putting them in the drones and getting a totally different perspective in the morphometrics and the volumetrics and visual health assessment and even the biosampling, collecting a breath analysis, okay? And then you could go from there to acoustics. Acoustics, well-founded, basic tool that's very cost-effective in many ways, but you can put the acoustics on the telemetry, combine these techniques, and put it on a suction cup tag, put it on the back of a whale. Let's say it's an entangled whale, and there you can measure the energetic cost of being entangled, because all the sensors packed in that one tag is feeling fluke beats and pitch and roll and the movements of the animal, the dive profile, and the acoustics. And I'll mention the acoustics because when it comes to rescuing a whale, you've got a combination of things to do. You've got the assessment towards reduction. Okay, gaining information towards reducing the threat, but now you're part of the environment, and you've got to assess your risk assessment for you. And I'd say half the time, we get whales show up with our whale that changes the dynamic, makes it actually worse, and we're wondering, are they calling them in? We'll use the acoustic package to help us operationally as well. So really, again, just an array of tools that, again, I'm using my doctor analogy, and I'm using my analogy with humpback whales. It would be nice to get ahead of the curve so we're not to the point of vaquitas and North Atlantic right whales, and monitor that population, have them be our litmus paper, have them be our canary in the coal mine, and use all our tools and our specialists at hand. So there's my message point there. Thank you, guys.
So thank you all, and I'm sorry that a session on technical stuff has technical difficulties. I guess that's how the world works.
Yep.
So I might just make the comment that, in this group of us, we increasingly follow the activities of individuals within populations. Yesterday, we received words of both a right whale calf up in the St. Lawrence estuary and a dead right whale in the St. Lawrence estuary. And it's kind of like a town. You go into a town in North Dakota and you cross off and you subtract one from the population. We're all thrilled that there was a southern resident killer whale calf sighted in J-Pod out in the Pacific Northwest. And we also talked about vaquitas. We hear about the next vaquita being found, caught in a gill net. So I wanted to ask a sort of philosophical question. How do we balance between the kind of immediate, let's get a whale untangled, and the longer term, we've got to draw attention to this. We've got to help populations overhaul. So be curious in sort of quick responses to that question of prioritization.
So I could
I'll
start.
go with Mike first. Michael.
Do you want to go?
Go ahead, Mike.
You go.
I'm a veterinarian. I get trained in diagnostics and treatment. And I started off my career in diagnostics, and we did some treatment with sedation to help disentanglement. But ultimately, it all comes down to prevention. And I've hung up my whaling knives and all that. And I'm writing a book about the philosophy of how we fail to represent the impact of consumerism on marine mammals. And so I'm into the prevention part of my career at this point, simply for that reason. So yeah, the individuals are all utterly important, because without an individual, you don't have the species. But the biggest threat, this is kind of crass, but the biggest threat to the North Atlantic right whale is you and me and consumers, and the failure of the political process to balance between industry and consumerism and how these things are working.
Ed?
Yeah, I can add to it. There's two ways of looking at that. There's the immediacy, because I'm in the response field, where you're trying to balance, get the animal cut free, but at the same time, trying to gain that information, okay? And of course, the operational risk assessment is going to be the priority, keeping people safe, and then secondary gathering information. And then there's the big picture of you've done that case and you're preparing for the next one, is wanting to gather that information, start working it up towards prevention that Michael mentioned. And that's a tough one too. And I find out, again, we have to take our roles. I know my role sometimes is getting the information and handing it over to someone like Michael, who might work up that data and analyze it for me. And we work as a team in that regard. Everything's a team. It's a big collaborative effort. So.
All right, Tracy?
And I just want to add that every individual case and animal has a story to tell. Our rescue program at the Mystic Aquarium, we use it as an outreach tool. We're not only helping animals, but we're learning, why are these animals stranding? What is the situation out there? And we're gathering that information through research, but then it's telling the public about it. And I think utilizing those animals for the greater picture and moving forward and getting them behind that is how to utilize those individual animals as well.
So I'm going to move quickly, because this guy is pointing times as we go, but we're doing all right. And I want to combine a question from the audience with one of our questions, which is about the involvement of communities. And I got a specific question about how do you involve young people into these efforts? And I wanted to call on Tracy first, and maybe on you in terms of your public awareness efforts.
Yeah. One of the things that we've done is when we're on the North Slope in the villages, gathering data on belugas, as we've engaged the youth to help us collect the data. But importantly, we then bring those students back to the aquarium. We take them out of the village, out of the state of Alaska. We bring them to Mystic Aquarium for a week. And we take those samples that we collected in the field, we bring the students in the lab, and we work side by side with those students to spin down the blood, to make blood smears, to learn about all the things that we're learning about the health of the animals. The goal is to get the kids excited about science, to want them to continue on with their education, but importantly, it's also our hope is that they'll become wildlife managers for their own community and sustainability of belugas, which is a major focus. We also emphasize the cultural components with our Native American students, local students participating with them, and then bringing those Native American students up to Alaska as well. So there's an exchange of not only science and learning, but also culture.
Okay, Keith?
We're doing two things. One, on the image collection side, we're partnering with the whale watching boats, specifically the New England Aquarium, Boston Harbor Cruises Whale Watch. And as people are out there, one of the things we're doing is we're doing plankton photography and tows and bringing microscopes. And so not only can people be engaged with the large animals, we're engaging them in the food source that makes the area so nutrient rich, and then giving presentations on the boat to the captive audience of people there. Another thing we're really doing through art, so the intersection of art and science and technology, is really looking at exhibitions and ways to use imagery as a catalyst to get people engaged to care in the first place, so that they can use public awareness to be able to sort of influence politicians, to help scientists and do things, and to have some attention to care about these animals, so that there is a compassion when there are only 500 of them and there's a will to actually act on some of these things. And so in many ways we're trying to bring people who can't reach out to the sea always, bring the images back to them and give them immersive experiences for that.
Okay. Now, I want to just stress how incredible these questions are that we're getting. I have like 25 questions. So I'm trying to, rather than sticking with ours up on the stage, I'm trying to combine them to stick with our technology theme, but also to pick up on some of the things we've said. So a basic technology combined question: what sort of trackers and satellites are used to track endangered whales? And then, as a corollary of that, will the acoustic devices on those interfere with the whale's echolocation? I don't know who would like to take that. Michael?
Sure. The trackers for whales are limited in the ability to stick to the animals. They are satellite-driven primarily, different qualities of position depending upon the generation of the technology you're using. But the longer they last, the more invasive they are, and that's a long discussion in terms of attachment troubles. And the shorter-term, high-density data come from the suction cup tags. So it's a complex piece, but I think it's important to talk about the sound as it relates to the acoustic pingers I was describing. And essentially, their duty is to be silent until interrogated. So they only make a noise if a question is asked of them from the boat. So essentially, it's not a background noise thing at all. And really, compared to the propeller noise or the exhaust noise of the vessel, it's relatively minor.
Okay. Anyone want to build on that, or should we go to the next question? Ed?
I mean, response-wise, it's tethered tag, so it's a different ballgame entirely. You don't have to worry about attaching it to the animal. It's just about getting back to the animal, or the animal doesn't give you the opportunity to cut it free to get back to it to finish the job. So it's a bit different in that regard.
So you're using them for immediately, here's an animal, attach it to the gear that it's dragging, and
Exactly.
then you'll be able to relocate it again.
Yep, but another tool in the toolbox that is very promising.
Okay. So the next one, I'm going to do another combination of questions, and this could take us the rest of the year. And I'm afraid Michael's going to jump to answer, so I'll see if anyone else does first. But how do you work to convince fishermen who are already so set in their methods to adapt to new policy to prevent entanglement? And then another one, which is related: shouldn't the Marine Mammal Protection Act or the Endangered Species Act mandate ropeless traps? And is there additional legislation needed?
I can make an introductory statement.
Yeah. Okay.
And that is, for the most part, fishermen do not want to catch whales. Okay, and I know that, a little side story here, I was doing this with Michael and others in New England, this whale rescue, and I actually walked out the door and said, boy, this is not the answer. And we all knew that wasn't the answer, that whale disentanglement wasn't the answer. And I ended up working with fishermen for a number of years in Massachusetts, trying to get at the source of the problem. And the issue is that they kept asking me, they knew where I was from, they knew what I had done. And they'd ask me questions like, could I set my gear here, could I do this, could I do that? They wanted the information just like anyone else, any other stakeholder, to reduce the threat. And I found myself being drawn back into an arena, an environment that got us that information. So that maybe, I don't know if that sets the stage, Michael, for you.
Well, you've got to make it work for them. And it's got to be affordable, and it's got to be safe, and it has to make sense, and it's tough. But certainly the folks that are most interested in the kind of approach I was espousing are those that are closed out. So Cape Cod Bay from January through May, you can't go lobstering. But you could if we could work it out such that you could do so without endline. And so that, I think, is the lever. And in terms of the regulations that drive it, we have yet to actually meet potential biological removal of the North Atlantic right whale since that regulation was placed, maybe whatever it is, 22 years ago or whatever it was. And so, yeah, I mean, the lobby from the industry is very strong because money talks. But honestly, there's a second half of that lobby that is relatively silent, which is, the conservation lobby. And so that needs to change, but it's not easy at all. And I always like to think of this debate as a debate with my neighbor, the lobsterman. Now, he's not a lobsterman, but he could be, or she could be. Mm-hmm. And that, I think, is an important philosophical and mutual respect approach that has to be taken to make this all work out.
Okay. So I have a couple of questions related to marine protected areas. So I'll ask it. First of all, we're really pleased to be here under the banner of the National Marine Sanctuaries Foundation. And so I'd like to hear more from those who work in sanctuaries of the value of sanctuaries to large whales, but also add the question from the audience that marine protected areas do not necessarily protect the entire range of migratory whales. How can we ensure their safety during migration? So, do you want to talk about
I can't speak about the protection of it, but I can talk to the region. I mean, Stellwagen Bank was designated as a special place because of its unique topography or underwater, which is it has deep water and a sand bank, and at about 100 and 110 feet. And there are a lot of fish that congregate there, specifically sandlands. And those populations of fish attracted the whales that are a unique population of Stellwagen Bank humpback whales that come to our area, or that area in particular, and people are able to see it. And so it's a special place that is accessible to everyone, much the same way a national park is on land. It's accessible to everyone. You know, it's complicated how you deal with the policy and the rules and all the protection, but I can say that, you know, it does do protection of like some things or lots of things, but the spirit of it is that it's a place for the public to be able to access and enjoy, while at the same time not a place that is detrimental to the animals where they won't be able to thrive. And so any things that are happening within those places that cause that kind of problem are typically, well, I'll leave it, not allowed.
I think I'll add, just to broaden the scope, is just that holds for all the marine sanctuaries, all the different sites and the monuments. They're important places. They protect important animals, populations, habitats. Many of them are ecosystem-based. And if they're not, they're specific on a species, on a population, or maritime heritage, you know. And that's, I'm going to use that because I think one of the strengths of sanctuaries is just how broad their effort is. I mean, and yes, foundationally, it's education outreach. I think it's one of their strong points. But they have the research footprint in many cases. They have the resource protection, maybe in-house. And if they don't, they go out and get it. You know, partnerships or facilitate. Remember my doctor analogy, get the specialist kind of thing and put them in play. So I think they really fill in there and complement that whole conservation community very well. So.
Okay, I've also got several questions on ocean noise. So I think sticking to our tools and technology theme, I'm going to ask you to talk about the tools we have to measure the impact of ocean noise on cetaceans. How do we measure whale hearing, the effect of anthropogenic noise on cetacean activities? And many of these questions go to, what are you going to do about it? So if you want to go there, that's fine. But I think given the panel, I'd like to hear more on tools and technologies that we're using. I know, Tracy, you do a lot of hearing analysis, both in captivity, but also comparing it to Cook Inlet belugas with Manolo Costalote. So maybe that's
right. So Manolo's the acoustics expert, and Aaron Mooney at Woods Hole, but they're partnering with us, where our animals lay out and they're given suction cup electrodes, and we're measuring their auditory brainstem response. So it's much like a hearing test. But then what they're doing is they're playing back recorded sounds from Cook Inlet, such as pile driving noise and shipping noise, and looking at how that changes the hearing threshold of belugas. So it's a very powerful tool to use on individual animals to really gain some insight into different types of noise and how they may impact hearing. At the same time, we have our physiological tools, such as breath, where we can measure, take a breath sample before and after the sound exposure to look at the physiological response to sound as well.
Okay, any further discussion? Surely, anyone want to take up the issue of noise? No? Okay.
I mean, noise is key, given that cetaceans utilize communication almost in everything they do. So in their foraging, in their migrating, I mean, they need, and any type of sound could have an impact. And I think we need to understand that better. Because they're so reliant on sound in their environment, It's important. It's one of the big, in my book, it's one of the major issues right now.
Yeah, and it's one of the hardest things to quantitate, not in terms of the noise itself, but the behavioral effects and the stress effects are not easy to get at all. I mean, a dead whale's a dead whale when it comes to an entanglement or a vessel strike, but that's a much easier metric than it is to look at the broader, and I think very substantial impacts that both episodic and background noise have on these animals. But it's harder to really get at that and what it really means.
All right, so we've talked a lot about some very immediate impacts. Let's move toward more climate-related the changes in the environment-related impacts. We have both on the West Coast. This month we have a lot of reports of gray whale strandings. At our annual meeting in Hawaii 2 weeks ago, we heard a great deal about changes in the number of humpbacks who arrived and calved in Hawaii, changes in arrival of humpbacks and residency in, for instance, Glacier Bay National Park. On the East Coast, I think you've done work on the condition of right whales, which is both correlated with entanglement, but also perhaps with broader environmental changes. So I'm curious if you could talk about those phenomena a bit. And I'll let Ed start.
I'll start. There you go. Okay. Well, we can start with the gray whales because they just came from Alaska, and coming through. And they instigated UME, an unusual mortality event. I think the number, at least last week, was up to around 69 animals along the Mexico West Coast and in Alaska. I know we had done some humpback whale research off Kodiak and found a dead gray whale. But then moving right on to the humpback whales in Hawaii and in Alaska, indeed, for the last couple of years, the sighting rates have been down in many areas, calf production down. That holds for many areas, not all in Alaska as well. Additionally, in Alaska, emaciated animals, some animals showing up emaciated more so than you'd expect that time of year in their life cycle, and changes in food resource, all sort of hypothesized to be a result of changes in the environment. Could be cyclical changes, the blob, El Nino, North Pacific Decadal Oscillation. It could be long-term stuff, global change, climate change, things like that. And as I mentioned earlier, that population of humpback whales, at least, and the gray whales too, are a healthy population. So maybe they're getting up near carrying capacity. So we have our task cut out, a challenge, because of all those variables. Could be number D, all of the above kind of thing. And it's going to take a lot of people working together, all those tools that we're talking about, to try to figure out what's going on. We've got to figure out whether they're being impacted directly, toxins or starvation, or are they just habitat change? Are they going somewhere else where our effort doesn't lie? We just don't know they're going there. And certainly we're seeing that kind of stuff along the West Coast, humpback whales where we haven't seen humpback whales before. So that might be an example of it on the plus side, if you will.
Michael, are you willing to talk about the long-term element of North Atlantic right whale
absolutely.
conservation?
We've seen a major shift in right whale distribution where they've essentially largely abandoned the Bay of Fundy, which was a place that they went regularly and predictably to feed on heavy amounts of copepods there. They're showing up more in the Gulf of St. Lawrence. They were always there. It's not a new form, but it's definitely more of them. That means they've got to swim around Cape Breton to get there. So the whole balance of energy for these animals is really, really important. And so the only income is what you eat. The expense can be what you expend for calving, for getting pregnant, for migrating, but also we've essentially coined the phrase of an anthropogenic life history stage for when they're entangled, they're getting the energy dragged out of them. And so it all comes down to the net balance as to what energy supplies you have. And essentially, the level of entanglement drain on the income that they've got from the food doesn't seem to be adding up anymore. So the nutritional balance of these animals is really important in terms of reproductive success. Any veterinarian or farmer will tell you that if you don't feed the cow, she's not going to get pregnant, you're not going to get the milk. And it's the same for a whale.
Thank you. Now we're only a few minutes left, and I want to go back to what was going to be my first question. It's kind of like one of these TV panels. I want you to describe in 2 sentences or so, like, we're here for the excitement of whales, the awe of whales. So I'll say one thing that I saw was we had 165 whales in Cape Cod Bay on April 6th or 7th. That's more than a third of the entire North Atlantic right whale population in one place. To me, that's awe-inspiring. Individual encounters, whatever. I mean, go down the row and we'll finish up with things that really have awed you about large whales or experiences.
I mean, for me, it's inspiring every time, but there's, in being in the water with them, there's an inspiration of a presence that you, especially because I can't always see them from far, so there's a presence of feeling just a large animal near you before you can actually see it, which is a really magical and mystical kind of feeling. And I think as someone who connects, it's a lot of photography for me underwater is being able to establish that connection or a feeling of trust in those moments. And I think while they may be brief, I believe for both of us, it's an interaction that we will remember. And I think that those pictures encapsulate that specific time. And for me, those are incredible moments. I hope for the whale as well, actually.
So maybe not.
Michael.
I want to expand on the drone story, the wonder that I've seen in the last few years. We've also been using an infrared camera on the drone. And we've noticed that there's a difference between animals that are surface skim feeding and those that are subsurface. The subsurface skim feeders don't seem to have a lot of heat loss problems because they can radiate. The ones that are surface feeding with the mouths, with the rostrums out of the water, they're blushing because they can't get rid of the heat because you can't lose heat in air so well as you can in water. And when I realized that these whales were blushing, it was really special.
Wow. Tracy.
One of the most awe-inspiring moments I've had is I had the privilege of going up to the high Canadian Arctic where the water is crystal clear blue, but it's freezing cold. But it looks just like the Caribbean. And 1,000 belugas, there must have been 1,000 of them that come into the mouth of the Cunningham Inlet. And we could observe and watch their behavior. They were from me to where the seats start. And we just had such a clear picture of their social dynamics. And we could hear all their vocalizations. And it really was, it looked like belugas on summer break, just having a great time. And it was, I'll never forget that. It was incredible.
I think for me, it's going to be the response. I'm heavily involved in it. And the scientist in me knows that you've got to go for the prevention side of things, as Michael and others have said. And yet when you're working on that animal and you see the impact of it, it can draw you in. There's an emotional side. And I do a lot of trainings. I work very closely with NOAA Fisheries and the Marine Mammal Health and Training Response Program as part of this, nationwide. And we've got to remind ourselves in those trainings that you've got to set that aside. You've got to let that impact not be there at that moment. Get the animal free, get the information. Afterwards, if you want to celebrate or a pat on the back kind of thing, it's okay. But that's always there. And it's just amazing after the number of years, it still hits you. It can hit you hard. So.
So I want to thank my panelists. It's been really fun. As I said, I have a lot more questions. We could go on for a long time. And we really have left a lot of questions unanswered. There are many unanswered questions, some really tough situations, really beautiful images, immediate crises to deal with, native communities to work with on incredibly important issues. So thank you all, and thanks to the audience for the questions.